This is the only problem we need to talk about. Two posts, one 12 feet high and the other 28 feet high, stand 30 feet apart. So before I even finish reading the rest of this problem, I'm just going to draw a picture. We have one that's 12 feet high and one that's 28 feet high. So maybe I'll draw that 12-foot high one there, and then the 28-foot high one there, and then it's 30 feet apart. Okay? And then this one's 12, and then this one's 30. No, 28. Okay, now they're stayed by two wires attached by a single stake between them. So what that means is at the top of each of these posts, we have a wire. It's a single wire. And it's drawn out like if it's like loose. If there wasn't a stake on it, it would just be hanging here kind of loose. But what they did is they put a stake on it so that this single wire is tied down like right there. And my picture obviously is really awesome. So let me fix this so that it looks a little better. Oh boy. Let me undo that. And come on, undo. There you go. Now I got to erase it again. Now I got to change colors. Okay. It's green. Okay, so it's like horizontal ground we're kind of assuming here. Such that the wire runs from the stake to the top of each pole. So here's the stake, here's the top of the pole, stake, top of the pole. Okay, now it's a single wire. It's not broken. It's not connected this wire and then connected here and then this wire is connected here. It's one wire staked to the ground. That's important. So where should the stake be placed to use the least amount of wire is the question. So let's think about this for a second. If I put that stake all the way over here, how much wire would I have to use? Well, I'd have to use 12 plus whatever the Pythagorean theorem gives me for that distance right there, right? If I put it all the way over here, then I'd have to use 28 plus whatever the Pythagorean theorem gives me for that distance right there, right? The idea is we need to be probably somewhere in between, because if I'm outside of that, I'm just going to use even more wire than I would if I was between. So somewhere in between, here and here. Could be here, but it's somewhere in between. We have to use a minimum amount of wire. Okay, so that's the idea. Now what do we do?
Primary equation.
Okay, a primary equation would be what? No. What are we trying to minimize? The length of the wire. So we need an equation for the length of the wire.
So hypotenuse plus hypotenuse?
No. How about length? If I call this y and I call this z, then the length of the wire equals y plus z.
Oh, so then a secondary equation.
Now the secondary equations are going to use the Pythagorean theorem to get rid of this y and this z. And I specifically used y and z because I want to use x for my secondary equation so that in the end I wind up with the variable x. Okay? So if this is ground right here, in fact I'll even make it green so it looks like ground. Sorry. Okay, so that's the ground, and we're talking about Pythagorean theorem here. So what I want to do is define this length right here. Let's call it x. And if this is x, then what is this length? 30 minus x. So now, I have this length right here, right? It's 12. Okay. Where were we? Oh, right, I remember now. So we have x here, and we have a length here. So if I find the Pythagorean theorem and I solve for y, I'll be able to have the equation for the Pythagorean theorem sitting there in terms of y, which means I'll be able to substitute what I get in for y. And the same thing is true over here. I'll be able to solve the Pythagorean theorem for this triangle for z and substitute that in, and I'll wind up with w equals something in terms of x plus something in terms of x. Then I'll have just that one variable and I can take the derivative. Okay, so that's the plan. So we need to come up with an equation for this guy right here. What are we going to write? Y equals, yes. Okay, and 12 squared is, so I have 144 plus x squared. Or I could write x squared plus 144. And for this one over here, which I don't know. So I'm going to write it down like that.
784.
Oh, 784, okay. So z equals square root plus 784. Now what? Before that. Rewrite the primary equation in terms of what we now have. So w equals, that's a w, equals the square root of 144 plus 784. Okay, so now let's try to think of what the feasible domain is going to be. X has to be positive, right? X has to be greater than or equal to 0, or greater than 0. Okay, now what's the biggest number that x can be? X has to be less than 30. So think about where this stake is right here, right? This stake kind of moves from side to side. It can go all the way over here to 0. It can go all the way here to 30. Okay, so x has to be somewhere between. So there's your feasible domain. So we will test when we take the derivative of this, which we will, and we find critical numbers, which we will also have to include x is 0 and x is 30. Okay? So if I plug 0 in right now into this, I have the square root of 144, which is 12, plus 30 squared plus 784, whatever that is, the square root of that. Okay? That's going back to what I said, where if we put the stake here, we have that 12, which we got right here, plus whatever the Pythagorean theorem gives us for that distance right there. Okay? If I plug the 30 in there, then this slides all the way over here, and now this reduces down to the square root of 784, which is 28, plus whatever we get for the Pythagorean theorem here. So the 0 and 30 definitely need to be included in our little analysis of what we're doing. Okay? And it's equal to. Because of that. So, now what do? Take the derivative. I want to rewrite this as to the 1/2 power, because that's what we know how to deal with. So w equals 144 plus x squared to the 1/2 plus 30 minus x squared plus 784 to the 1/2 power. All right. Take the derivative. W prime equals 1/2 times plus x squared to the negative 1/2 2x. Okay, the other one? Plus. Bah! I'm going to write this down here. 2 times no. So to the first power and then times negative 1. You were kind of right, but so I'm putting that right there. That looks kind of maybe. Now what? You want to simplify it? Okay. So what happens right here? the 1/2 times 2x, but then this is in the denominator. Good. So w prime equals the over okay. Is it plus? With this -1 here times 2 times positive 1/2, it turns into negative. So we write minus, and it is -1 times what? Where? Okay. Over some stuff. Like that. Now we set it equals 0. Find our critical numbers. And I'm just going to slide this a little bit. There we go. Now what?
Well,
It's equal to 0.
we can add one of those.
Why would we do that?
Or we could find a
Common denominator.
Why would we do that to ourselves?
No, actually your first idea was the correct one, but I'm wondering why. So yeah, the idea is this guy is going to move over here, and then what can we do to start solving for x? Eventually, I mean, that's how you solve for x, right? Tell you what, let's write it down. Maybe we can see it then once it's written down. So this is going to move over here, which means now I have x over equals. No. Is that 30 minus x? Why are my minus signs disappearing?
You just never drew it in.
No, they're there. Okay, how do we solve this for x?
Cross multiply.
Yes, cross multiply. Cross multiply. No, that's right. You got to get rid of the proportion, right? So let's cross multiply this mess. So you sound so hopeful. X times this. So that's this. And then this. Okay. Wonderful. Now what? Can we take the square roots? We cannot take the square root of things that have more than one term in them. But nothing. Here, let me give you an example. If I take the square root of 4 plus 9, if I take the square root of 4, I get 2. If I take the square root of 9, I get 3. 2 plus 3 is 5. Is that what the square root of 4 plus 9 is?
No,
The square root of 4 plus 9 is the square root of 13, which is definitely not 5.
okay, so that was wrong.
So that doesn't work.
Well, what if we can make a really nasty fraction if
We just got rid of our fraction.
I think it's a good idea about here. You know how.
I can't distribute in either.
Square root.
I can't do any sort of multiplying with those square roots there. If they weren't there, then sure. Square them. Square everything.
Yeah, why not?
Square everything gets rid of the square roots,
Yeah.
right?
I thought we already said that. You said
No. You wanted to square root everything. If you square everything, because of the fact that we have just multiplication going on here and here, That's not a big deal. If you had other things going on, then you would have to probably FOIL, and then the square roots wouldn't necessarily disappear, which is a bummer. But in this case, we can square everything. So, squared, squared. So what do we get? You get x squared times, what happens here? That goes away. So now I have this. 30 minus x squared plus the 784 equals, what happens here? 30 minus x squared
Times
144 plus x squared.
All right, here's what I want to do.
Yeah?
Take the x squared
Yeah.
and put it next to those terms.
What do you mean next to?
We don't actually want to find the most.
What?
Distribute the x squared.
So take this and put it here and put it here,
Yeah.
but don't FOIL that out.
Yeah.
Why would we? Because we can divide it out
We
right
just
there.
want to,
We can.
We get a 51 eventually.
The problem is you have two terms here. If there wasn't a 30 minus x squared in this term right here, then yeah, you could, but that's not going to happen. So I like the thought though, but it's not going to work. So what do we need to do? FOIL everything out? That sounds awesome. I don't want to FOIL everything. X squared times 900 minus 60x plus x squared plus 784 equals 900 minus 60x plus x squared times 144 plus x squared.
now again.
Keep going. Okay. No, we can't. It would be so nice if we could, but we can't. Keep going. So, what does this turn into right here? 1684? And then I distribute the x squared in? I don't want to distribute the x squared in? Why factor? So this becomes x to the fourth minus 60x to the third plus 1684 x squared.
Equals. Wait, I got it.
I'm going to do this.
Guys, it's 129,600.
What is this one?
It is 129,600.
Oh, that's awesome. What's this one?
900, negative 54,000.
60 times 144.
Oh, sorry, I did 900. Sorry.
Goodness.
My bad. Oh, so that's only negative 8,640.
Oh, that's
This
easy.
is an awful problem.
And then 144x squared. And then 900x squared. And then negative 60x to the third. And then x to the fourth. How'd I do? Okay? All right, perfect. So now we have over here x to the fourth minus 60x to the third. Oh,
Hey guys, we're doing good. Just keep going.
Keep going.
combine like terms on the x squared. plus 1044 x squared minus 8,640x plus 129,600. All right, and we already saw the x to the fourth and the x to the third terms go away, which is lovely. So now I'm going to subtract. So these guys are gone. Let me just get rid of them real quick. Gone, 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 gone. So now I'm trying to solve for x, so I'm going to get everything on one side equals 0 on the other. Subtract the 1044x squared from both sides, and I get 640x squared. I got to move this guy over, so plus 8640x minus 129600 equals 0. So maybe we can factor. If I divide everything by 640, is 8,640 divisible by 640? Okay, we can get rid of a 0. Nice. 64x squared plus 864x minus 12960.
Yeah, I was just thinking that we should divide by 2.
They're all divisible by 4. So how can I solve this? Four?
But then you do that with 4 equals 0.
Oh man, we got to do the Punnett squares.
No.
What?
There's no D in
A
Punnett.
times D, guys. I was thinking that, but no.
I just want to reduce this so we don't have to work with such huge numbers.
Just divide by 4.
Okay, so what's 64 divided by 4?
Divisible by 8.
Yeah.
It's all divisible by 8. So we got 8x squared plus 108x minus 1620 equals 0. So that's all still divisible by 4. So this is 2x squared
Oh, much better.
plus
We had a calculator.
27 minus 405. Now we're getting somewhere.
Okay, now Punnett squares.
Yeah, if you want to figure out what two numbers multiply to give you 810 and add to give you 27.
I feel like that's going to be a nightmare.
Well, one of them's negative.
Or we could do the
It could be anything, guys.
quadratic formula.
We could do that too.
X equals
Yesterday you wanted to do it.
Plus or minus, it'll be.
negative 27 plus or minus the square root of, what is 27 squared?
I don't know.
Something less than 900. 729 minus 4 times 2 times negative 405. So that's nice. We won't have an imaginary solution. All divided by 4. X equals negative 27 plus or minus square root. All of this turns into 729 plus
What else?
805 times 4.
810 times 4.
Sorry, I forgot.
So what is that, 3240? Somebody do that for me. We've come this far. I don't want to make a dumb mistake now.
4 times 8, 10.
3240.
3240.
All divided by 4. So what's 729 plus 3240?
3,600. No, not 600. 969.
3969. Square root that. What do we get? 63. Woo. So we get x equals negative 27 plus 63, which is probably 36 divided by 4, which is 9. And x equals negative 27 minus 63, so that would be negative 90 divided by 4, which is terrible. Negative. We can't have a negative, so we get negative here, so no. X equals 9 is the answer.
Now we go all the way back.
So now we go all the way back up here. And we're saying when the peg is 9 feet away from the base of the 12-foot pole, we have a critical number. The question is, what does that critical number tell us? No, what we want to do is plug this into the second derivative.
Because that'll give us a bit.
Okay.
So we got to take the derivative of this.
Oh my goodness.
I'm ready.
No,
Oh, let's
We're-
use the first derivative test.
use the first derivative test, please. So basically what you're doing is you're going to set up an interval now from 0 to 9, and then from 9 to what we said, the 30.
Okay.
Right? If you want to use the first derivative test.
Yeah, we don't want to take the derivative of
Or, you know you have to check when x is 0, you have to check when x is 30, and you have to check when x is 9. So how about you just use this equation right here and figure out how much length you have for each of those 3 cases. And whichever one comes out the smallest is the winner.
that. Yay, winner. Okay.
No,
Are you sure?
there's only 6 problems in the homework. So maybe it's 7. Anyway, the answer that you get in the end is actually when x equals 9. See, look at that. Things are disappearing. When x equals 9 is the answer. Okay? So, persevere through the problem. Even though this one is super ugly, and that's why I saved it for last.
You should leave that up for
Yeah, I was just thinking that.
and like,
Get the algebra.
You can do all this math though, right?
Yeah.
yeah,
I mean-
we did it.
The hard part is the setup.
Guess we didn't have to take the derivative.
No, the hard part was the algebra.
Okay, the hard part was the algebra. But if you understand this, if you can get the problem set up, you can do the math to get through the problem. That's the point.